June 5, 1944. In a cramped operations room somewhere in southern England, military engineers watch an enormous wheel slowly rotating. This is not a weapon, not an aircraft, not a warship. It is a machine designed to pump petrol, thousands upon thousands of gallons of it, beneath 80 kilometers of dark, cold water. In less than 24 hours, the largest amphibious invasion in human history will begin, and this humble apparatus will determine whether the entire operation succeeds or collapses in catastrophic failure. The men in that room know what no German intelligence officer has yet discovered. Lying, coiled on the seabed beneath the English Channel, is a lifeline that will literally fuel victory. They call it PLUTO, pipeline under the ocean. To this day, it remains one of the most audacious, technically brilliant, and thoroughly secret engineering achievements of the Second World War. This is how 500 miles of invisible pipeline hidden beneath the waves changed the course of human history. The invasion of Normandy presented a problem so seemingly insurmountable that many planners believed it could never be solved. An amphibious assault of this magnitude, over 150,000 soldiers, thousands of vehicles, countless aircraft, would require, according to conservative estimates, between 4 and 5 million gallons of petrol every single day. The conventional method of supply, using conventional tanker ships that would dock at captured ports, faced a catastrophic difficulty. The main ports of northern France were exactly where the enemy expected them to be. The Germans had spent 3 years systematically fortifying the harbors from Cherbourg to Boulogne, turning them into bristling fortresses protected by anti-tank guns, minefields, and artillery. Capturing a usable port would take weeks, perhaps months, but the invasion force would run out of fuel and therefore momentum within days. Petrol, as one military historian later wrote, was more precious than blood. Every lorry, every tank, every jeep, every aircraft would grind to a halt without it, and a stationary invasion is a dead invasion. The logistics officers calculated that even with perfect conditions, traditional supply routes using cargo ships could deliver no more than 25% of the required fuel. 3/4 of the demand would simply go unmet. The mathematics were clear: without a solution, D-Day would fail. And so, in the most unlikely of places, a solution began to take shape. The inspiration came from an unexpected source. Early in the war, the British military had experimented with flexible pipes made from paper layered with wire and rubber, originally designed to carry water across desert terrain. The concept was simple but elegant. Why limit supply chains to ports? Why not lay the supply line directly where it was needed? By late 1942, military engineers began serious work on an adaptation of this concept, specifically designed to carry fuel beneath the sea. What started as speculation in a few planning meetings became an officially sanctioned project under the code name PLUTO, headquartered at the humble location of Richborough, a small hamlet in Kent. The engineers assigned to the task came from various firms, most notably Siemens, a British subsidiary, and Callender's Cable and Construction Company, which held the intellectual property for the flexible pipeline technology. Callender's took the lead on design and development, working in conditions of absolute secrecy. Not even all military personnel knew what was being created. The official cover story was that the work involved research into underwater cables. The technical challenge was extraordinary. A pipeline capable of carrying petrol at high pressure across 80 kilometers of open sea, subjected to constant movement, temperature fluctuations, saltwater corrosion, and the vibrations of the tidal flow, had never been attempted before. The engineers designed what they called a conundrum, or contiflow system, a flexible steel pipe, 4 centimeters in diameter, with a rubber core reinforced with layers of steel wire. The entire assembly was then wrapped in protective jute and steel tape to withstand the rigors of installation and operation. Each section measured approximately 900 meters in length, light enough to be handled by existing cable-laying equipment, but strong enough to withstand pressures of 140 pounds per square inch. The innovation was genuinely revolutionary. To put the pressure in context, this was equivalent to the force exerted by water at a depth of approximately 100 meters. One end of each section was fitted with a coupling mechanism, a clever hydraulic design that allowed two pipes to be joined together while completely submerged. This was an engineering marvel in itself. The system required no valve to shut it down between connections. The hydraulic mechanism prevented spillage through sheer pressure dynamics. But designing a single pipe was merely the beginning. The complete system required 17 separate pipeline routes, each carrying fuel across the channel from various points on the English coast. Some routes would terminate at ports already in Allied possession. Others would tie into floating harbors, the artificial harbors codenamed Mulberry that were being constructed in secret shipyards across Britain. The pumping stations at the English terminals were disguised as innocuous industrial buildings to avoid German reconnaissance. The actual manufacturing of all this pipeline took place in factories in Preston, Sheffield, and other industrial cities, with components transported under armed guard and assembled in closely guarded facilities. By June 1944, approximately 4,000 miles of total pipeline had been manufactured, far more than would ultimately be needed, but accounts had to be hedged against breakage, enemy action, and unforeseen technical failure. The installation began in earnest in March 1944, some 3 months before the scheduled invasion. Specialist cable-laying ships, originally designed for underwater telegraph cables, were requisitioned and adapted for the purpose. The ship responsible for much of this work was HMS Sancroft, a vessel that had previously seen service in the First World War. As the pipes were laid in carefully predetermined routes, the operation remained so secret that even many of the sailors working on the cable ships did not fully understand what they were installing. They knew only that the work was of tremendous importance and must proceed without delay. Weather proved a constant adversary. The English Channel is a treacherous stretch of water, particularly in spring, and rough conditions in March, April, and May caused several delays. At one point, over 2,000 miles of pipeline had been successfully laid, but German observers had begun to notice unusual ship movements in the channel. A carefully orchestrated deception campaign, codenamed Operation Fortitude, deliberately drew German attention toward other areas and away from the pipeline installation work. By June 4, 1944, with the invasion just 2 days away, over 300 kilometers of pipeline had been successfully installed on the seafloor, with the final sections in place even as the invasion fleet prepared to sail. The moment those pipelines began operation, they transformed the invasion logistics entirely. On D-Day itself, the pipelines were already delivering fuel, though at modest volumes, whilst pressure systems were being pressurized and tested. Within days, however, the flow increased dramatically. By mid-July 1944, barely 6 weeks into the invasion, PLUTO was delivering 500 barrels of petrol every single day through its primary routes. This does not sound dramatic in written form, but translated into reality. 500 barrels equals approximately 80,000 imperial gallons, enough to fuel over 5,000 heavy lorries driving 50 miles each every single day, completely supplying the rapid advance inland that broke through the German defensive lines. The pipeline's true significance lay not merely in the fuel delivered, but in its reliability. Traditional tanker ships were subject to German air attack, bad weather, and harbor congestion. The pipeline, running invisibly beneath the waves, was nearly immune to such interference. German efforts to locate and destroy it failed utterly, primarily because German commanders could barely conceive of such a system existing at all. If you are finding this interesting, a quick subscribe helps more than you know. The algorithm, rather like the German Army in 1944, has absolutely no idea what it's doing with my videos, so your subscription is the single most reliable way to support this channel. The British innovation was, unsurprisingly, not without precedent in German military thinking, though their efforts had proven far less successful. Germany had experimented with undersea fuel pipelines of their own, notably in supplying the Mediterranean theater during operations in North Africa. However, the German pipeline systems were smaller in scale, less reliable, and ultimately more vulnerable to Allied air attack because they operated at shallower depths and through more confined geographical spaces. The American military, whilst impressed with Pluto's performance, never implemented a comparable system during the Pacific War, partly because the logistical situation was fundamentally different. Island-hopping campaigns could establish supply depots more easily than a rapid push across an entire continental theater. However, American engineers carefully studied the British design, and elements of the Pluto concept were later adapted by the United States Navy for operations in Korea and Vietnam, though these were never deployed on the same scale. The technological advantage conveyed by Pluto was distinctly British, a reflection of the nation's long experience with naval engineering and underwater cable technology stretching back to the first transatlantic telegraph cables of the 19th century. No other nation possessed quite the same combination of technical expertise, industrial capacity, and desperate necessity to drive such an innovation forward. The actual impact of Pluto on the military outcome of the Normandy campaign remains, by necessity, somewhat difficult to quantify with precision. Military historians broadly agree that Pluto did not, in isolation, win the war or even the invasion. Victory resulted from overwhelming military superiority, excellent planning, and the extraordinary courage of the soldiers involved. However, Pluto made the difference between a slow, grinding advance inland and the rapid breakthrough that became possible. Traditional tanker ship supply was simply inadequate for the pace of advance that Montgomery and Eisenhower achieved. Without Pluto, there would have been delays of weeks, not days, at critical junctures. Such delays might have allowed German reinforcements to arrive in theater, might have permitted German counteroffensives to be mounted with greater effect, and might have fundamentally changed the trajectory of the campaign. In military logistical terms, Pluto was the difference between success and catastrophe, even if that difference did not manifest as a single dramatic moment or lost battle, but rather as the accumulation of days gained, momentum sustained, and German defensive capabilities overwhelmed before they could be fully mobilized. The supply pipeline ultimately delivered over 172 million gallons of petrol to Allied forces during the 8 months after D-Day, accounting for 1/5 of all fuel consumed by the British and American armies in France and Germany during that period. For context, this volume of petrol, placed into lorry-sized containers stacked 5 high, would create a line stretching over 300 kilometers. This fuel powered the very vehicles and aircraft that drove the Nazis from France and into final defeat. The aftermath of the operation saw Pluto gradually fade from public knowledge, hidden away behind both military classification and the simple fact that pipelines, unlike tanks or aircraft, are inherently unglamorous subjects for historical commemoration. The wartime installation was eventually decommissioned, though some of the original pipeline remains on the seabed to this day, a ghost of the vital artery it once was. However, Pluto's legacy extended far beyond the Second World War. The technological advances in flexible underwater piping, the coupling mechanisms, the pumping methodologies, all of these were carried forward into the post-war period. American and British petroleum companies, facing the challenge of delivering oil from distant fields, studied the Pluto designs carefully. The Trans-Arabian Pipeline, constructed in the 1950s to carry petroleum across the desert, directly incorporated lessons learned from Pluto. More significantly, the technology formed the conceptual ancestor of the North Sea oil pipelines that would become crucial to British energy independence in the 1970s and 1980s. A pipeline laid in secret in 1944 to fuel invasion tanks had inadvertently provided the blueprint for national energy security 40 years later. Engineers working on undersea cable systems, including the submarine telecommunications cables that form the backbone of global Internet infrastructure today, continue to use principles established by Pluto's designers. Few military innovations have had such extensive civilian applications. Few wartime projects have left such a lasting mark on technological development. In June 1944, as the Allied invasion force pushed inland from the beaches, German High Command remained largely unaware of the 500 miles of pipeline quietly delivering the lifeblood of invasion logistics beneath the waves. When, months later, German analysts finally understood the scope and sophistication of the PLUTO system, they were simultaneously impressed and appalled. Here was proof that the British, the Germans concluded, possessed an industrial and technical capacity that German intelligence had dramatically underestimated. The psychological impact of this realization contributed to the growing sense in the German military that the war, despite occasional victories and tactical successes, could not ultimately be won. An enemy capable of conceiving and executing such a feat, laying hundreds of miles of precision-engineered pipeline across treacherous waters in complete secrecy, coordinating the effort across multiple military services and civilian contractors, timing its completion to the day for the largest military operation in history, must possess reserves of capability and determination that seemed, quite simply, inexhaustible. PLUTO never fired a shot, never destroyed a German tank. The first pipelines were pumping fuel whilst the invasion beaches still echoed with gunfire. By the time the ink was dry on the German surrender documents in May 1945, PLUTO had successfully delivered over 172 million gallons of fuel to advancing Allied armies. It had enabled the rapid breakthrough at Normandy, sustained the drive across France, and powered the final push into Germany itself. Today, if you venture to the cliffs of southern England or undertake a crossing of the Channel, you can visit the locations where these remarkable pipelines originated. The pumping stations have been dismantled or repurposed, but historical plaques mark their former positions. In a few museums across Britain, you can see surviving sections of the original pipeline, the steel wire reinforcement still intact, the rubber core still demonstrating the engineering brilliance of its designers. These humble lengths of metal and rubber stand as a silent testament to human ingenuity in extremity, to the capacity of rational problem-solving to unlock seemingly impossible barriers, and to the power of logistics, that most unglamorous of military disciplines, to shape the course of history. The next time you consider the invasion of Normandy and imagine the great sweep of landing craft approaching the beaches, imagine as well the invisible current of fuel flowing beneath the waves, carrying energy and possibility from one shore to another. Imagine the engineers at Richborough, watching their dials and gauges, knowing that the fate of millions rested upon their calculations. Imagine the scale of human organization and technical skill required to make the impossible real. And perhaps, when you think of war, you might remember that sometimes the most decisive victories are won not with thunder and flame, but in absolute silence, far beneath the sea.